So today I'd like to talk about blockchain and what I have learned so far. I'm a very newbie, so I just started like a month ago, or 2 months actually, and then I just try to learn as much as possible for this presentation. Okay, so my name is Noby Fujioka. I'm a front-end developer, and I love coding with React. And I'm, as well as a Bristol JS, I'm organizing Cheltenham JS, and I'm also part of React JS Academy in London. So please check them out. Okay, and then so now I discovered blockchain, and I'm very excited. I don't fully understand, but I'm really excited. So today I'd like to talk about 4 topics. So what is blockchain and its potentials, and a little bit about coding. Not too much about Ethereum programming, which I would discuss, and how it interacts with the front end, JavaScript, React, for example. And then maybe what's the maybe impact on how we build our future dapp. Dapp means decentralized application, because that's all about blockchain. So what is blockchain? Do people know about blockchain? I guess you know. Some people are experts. Some people know a little bit about it. Bitcoin, cryptocurrencies, yes. So it's kind of a buzzword as well. So just to explain, I try to explain blockchain, which is basically a digital ledger. Okay, so it basically writes transactions, any transactions, in a kind of block, and then you write one block, and then you connect another block, and another block, another block. So this is kind of a kind of summarized version of blockchain. So it's block 1, block 2, block 3, etc. And then you have some transaction going on. And then, okay, so maybe do you want to know a little bit? Do you want to see how it works? Yes. Okay, because I have lots of slides, so maybe maybe you can help me out. So this guy, Mr. Anders, built this website which explained the blockchain. So blockchain uses hash function. Okay, so when you type something here, some data, hello, hash changes. So it produces a hash, some specific digits. Some numbers. I think it's a hexadecimal number. You correct me if I'm wrong. So you just type hello world, and it changes. Every time it changes. And always when you type same word, it's the same hash. So it's not random. It's somehow the computer generates the same hash. So if you go back to the hello, it goes back to the same hash. Okay, so that's kind of the hash function, and the block. Block is okay. It's a data. Okay, it produces a hash, and if you look, maybe I can make it bigger. So if you look at this number here, hash, start with 0. Like there's maybe 40, depends. Blockchain defines how many zeros you have to have. So this means a signed block, because it starts with 0. So if I type something here, again like hello world, it changes, and then there's no more zeros now. So this is not signed. So we want to make it kind of official. You have to make some zeros at the beginning. So how would we do that? How do you think? So basically, there's no way to kind of to work it out how we can do it. So basically, what you have to start with like 0 and 1, 2, 3, and then you have to keep trying the different numbers. So because it's a combination of this number, block 1, and the combination of this number and this letter creates this one. So only thing, this is fixed, right? And this is fixed. So only thing you can change is here to make a zeros. Okay. So so you can't really do that. So basically, we ask computer to do it. So it's called mining. So computer will try many different combinations, and then voila. So it finds the combinations. So that number is 85869. Okay, so that's its signed block. Okay, and then blockchain just basically a chain of that kind of block. So interesting thing about this is so the first one is obviously there's no previous one. So if you let's change something here. So if you put like yo, and you have to mine it. Okay, so you can mine, and you put something else. So this is so you sign it, and then you create another one. Hello again, and then you mine again.
So the point is the hash of the first block is forming part of the payload.
That's right, that's right. Yeah, so please ask me anything. I'll try to explain as much as possible because I don't fully understand. So, but yeah, so basically it creates a hash, and then this hash will be taken to the next block, and then and then you have to mine it, and then you create another hash. So then another hash. So I won't put the words now, but let me just refresh this one. And okay, so let's say there are some words, but now it's all signed. So if you so if you change something, everything will break. So if you type something, as I said. So if you go back to the chain and then say hi, all the zeros disappeared, so it just breaks. So then, so you know that you kind of tampered with the data. So you have to, if you are someone trying to do kind of fraud, and then you just have to mine again from beginning. Okay, so maybe. So distributed blockchain. So there are now not only that has to be kind of proved with the mining, but also in a normal blockchain, like Bitcoin, you have different people having the same copy of the blockchain. So you have the same copy of the person A, person B, person C. So if you change something, one person change something, the blockchain will be different. And then when you look at the hash of the last hash, if you'll be connected to many blocks, and then if you look at the last hash and compared with other people, so most people have the same hash, but then if you have different hash, then we know that it's somebody that changed the information. So yeah, that's a blockchain in principle. Okay, so going back, So now, so basically in summary, the blockchain is like something like a Bitcoin. It is basically decentralized and distributed. So this is kind of more traditional centralized, like a company holds some information and you distribute information, or the banks. But blockchain is kind of peer-to-peer, and so there's no single point of failure. So if these are computers, nodes of the chain of the kind of network, and if this computer fails, still everybody has the same copy. Yes.
It's kind of the point is there's no single point of trust.
That's right. Yeah.
Right, because you can have a centralized ledger.
Yes.
With as much redundancy as
yes.
you want, but you're trusting one authority.
Yes.
And because the origin of
yes.
cryptocurrencies
yes.
is quite a political one.
Yes.
Of not wanting to have to trust central banks.
That's right. Very good. Thank you. Please help me out here. So yeah. So it's a network of computers, and decentralized, distributed, and immutable. Because if you change something, it just you can tell that you changed something. So it's immutable and secure, and no double spending problem. That means you can't just you have like single source of truth. So you can't have a copy of something. You can't just copy something or change something, and then that's a database. It's a ledger. It's a ledger that you have one single truth. Okay. Any questions so far?
Is
No?
it worth saying how the miners get rewarded?
Yes, okay. So that depends on the blockchain. There are many different types of blockchain platform. So that's a good question. So it's called a proof of work. And there are people who are mining, who are just like concentrating on trying to solve this cryptographic puzzle. So you know how to get to the 0, 0, 0, 0, and then you make a block. So these are called miners, and then they have like huge computing powers, and then they solve the block. And then once you get the approval for everyone, then miner get kind of rewarded. So they get like how many bitcoins or something like that. So it's a thing out of thin air, they get rewarded of Bitcoin or other currencies, cryptocurrencies.
The thing is that
yes.
only the person that
yes.
makes the block gets the reward.
Yes, that's right. So that is, yeah, that's right. So the other people don't get, and the people, lots of computing powers. But this is called proof of work. But there's other methods to not to do lots of computing powers. Proof of stake, but yeah, we'll maybe, if you have time, yes, we'll discuss. So the blockchain is first generation of the not the Bitcoin. Sorry, Bitcoin is the first generation of the blockchain, which became huge. Then we talk about Ethereum, which is the kind of second generation of blockchain, which is very interesting, which makes the blockchain very, very interesting. So, as I said, it's a first generation Bitcoin. And so what's the difference? So the Bitcoin is kind of almost purely financial transactions. You can do like send Bitcoin to one person's address to another person's address, but that's about it. Second generation Ethereum is what's interesting is that on top of the financial transaction, you can add smart contract. Okay, smart contract is basically digital contract. It's a computer program. And it's like takes all the goodness of the blockchain, so immutable, decentralized, distributed. So you can put some program, any program, on top of it, and you can run it in the global blockchain. So, and it can execute itself upon conditions, or you can make conditions. So it doesn't have to be controlled by central authority. Okay, so the potentials of blockchains. maybe. Or some people, actually some organizations already started to experiment. So like, for example, like financial transactions already, some crowdfunding. So a lot of blockchain platforms already raised some billions of dollars. And a lot of people speculative trading. So they use cryptocurrencies and as some kind of trading opportunities, but it goes up and down, so a lot of people lose money as well. Also, we could maybe potentially charities. So, like for example, World Food Program is experimenting some blockchain technologies to, for example, send money to individual projects in developing countries, etc. So it basically cuts middleman, and you don't have to pay lots of transaction fees to banks, etc. And it's very transparent because there's lots of transparency issues nowadays with charities. So you donate money, and then you don't know where the money goes. So yeah, and then you can have a smart legal contracts like real estate, will, or some legal contracts you put on a blockchain. Then you can't tamper, you can't change it. And so it's clear, and no government or somebody changing the record or something like that. You can use for voting or public records, maybe some identity on it, or all kinds of patents. And then you can probably use in the future like some global backend computer. So that's really exciting. There's some disadvantages as well at the moment. There's some issues like every time you make a transaction, change something in the blockchain, it costs a little bit of money. So for example, if you build like Twitter or something on the blockchain, at the moment in the Bitcoin, not Bitcoin, the Ethereum, every time you send a message, it costs you some money. So it's a bit of a problem with that. Yeah, and then you could probably use for supply chain, some tracking, some informations, some for transparency. So some people argue that maybe Airbnb or Uber or Amazon or any big company could be replaced by smart contract on the blockchain. Okay, so this is just like I took from some websites. There are lots of actually projects. We are not aware, but lots of projects going on, some trialing, like Mask or IBM. Yes, there's lots of companies, even maybe Google. Okay, so Ethereum programming. So okay, Solidity with React. The Solidity is a programming language, specially designed for writing smart contract on Ethereum blockchain network. And syntax is somehow similar to JavaScript, but strictly typed. And that's extension, file extension. So yes. Okay, so try Solidity on Remix. So there's this website called Remix. It's a web IDE, and you can try writing a smart contract. So here, if you click on that. Okay, so it's very simple. You can create a file. It's just very simple. Let me see. Can you see it? Maybe not. Okay. Okay, so it looks like some kind of object-oriented programming. So it's very simple. So you create a contract, like a class, and then you can declare some string, the variable called message, and you can have it's a string, and it's a public. Okay, and then your constructor, bit like a React, and then you can. I want to get some maybe some initial message, and then you attach the initial message to assign to message in a contract, and then you can call it, and also you can set a message afterwards. Yeah. So that's kind of simple contract. So yes, what's quite interesting is this is you can run a contract. You can write a contract here, and then you can write. You can choose an environment. There's a different network, like a JavaScript on your computer, virtual machine, or some things on a test network. And then you have your account, and then you can deploy. So if you deploy, just say hello again. Yeah, initial. Oops, sorry, I'm not used to this. Oops. Hello. Okay, so then initial message. I want to deploy the contract. So I'm going to deploy. Okay. Oops. Okay. So you also need something called the MetaMask, which is kind of where you want to make a payment or transactions. You can install this Chrome extension. It works only in Chrome at the moment. And then I want to issue this contract. So you have to pay a certain amount of money. Here it says 13 cents. Okay, and then just submit. This is a test. This is a test one. So I'm not having this money, but it's a test money. I have 12 Ether, for example, and then just submit. When you submit, it takes time because the transaction speed is very slow, blockchain at the moment. It will come up here. Actually, I'm going to do it on the virtual machine here. And then just say, hello. Okay, and then deploy. And then, sorry. Did it deploy? No.
I don't think it was in quotes.
Oh, here you go. Yeah. Here you can see, I didn't put any message at the beginning. Okay, but it doesn't matter. Here's the deployed contract. It's on the memory at the moment, but you can deploy it on a test network or actual network if you want. It's very easy. And then you can set the message. Again, yo. Actually, you need to put some code here. Yo. And then set message. And then doing some, okay, it's approved. But normally it's a real blockchain network. It would take a few minutes sometimes. And then I want to retrieve a message. And then you get yo. So that is just kind of quick. You can try this. It's quite fun. Yeah, as I said, you can install MetaMask to process the payment. And actually you can send some cryptocurrencies from one person to another. But you have to have an address, like some kind of numbers. Okay. All right, so that's that. And okay, so basically you can write a smart contract, and then on the JavaScript, your JavaScript project, you can import Solc, Solidity compiler library, and then just run it. And when you compile it, it creates a JSON object of your contract, which is basically consists of bytecode and ABI. So bytecode is like a computer, some numbers or the alphabets that you put on your blockchain. And then you have application binary interface. So this bit, you need to have it so that you can communicate with the JavaScript. to a blockchain to do something, to communicate with the contract. Okay. So to deploy, so in JavaScript you need to, basically you have a provider, network provider, could be, Ethereum has many different, actually mainnet and also test networks. Okay, these are different blockchain network. And then you basically tell the provider with the information, and there's another library called Web3, which is a portal to a blockchain. And then you create an instance of Web3, and then also create a new contract instance, and then you provide interface, and then you deploy with the bytecode so that the blockchain will take your contract and then give you back the deployed address. So where is the address? Yeah, okay, this is kind of important, so maybe I'll just explain quickly. So yeah, basically when you want to interact with, for example, React, so you, without going into the details, yeah, you basically you go through the Web3 library, and then you create an instance of the contract, and then you provide the actual deployed address. So it creates the kind of copy of your contract on the blockchain, but on your application. So then you just import it. You also want to have some functionality of Web3, so you import Web3 and you import my contract from wherever you put the instance in the same project, and then you can create an React app to interact. So here, I don't know if you can see, but basically, so for example, app, and then in a component did mount, you can, for example, in like earlier example of the contract, you have this inbox.methods.message that will communicate to the blockchain. I want to get the message, it's already recorded, .call, and then just you can save it on the state. Are you guys everybody familiar with React? Or yeah, I mean you don't have to use React. Actually, you can just use normal HTML and JavaScript. So yeah, you save it and then you can show it, and you can interact. So that's kind of basic. I made some application, but maybe not so interesting. So maybe I won't show it because it could be long. Unless you know. Later on you want to see. So now in the future, so what's going to happen? As you said, the kind of transaction speed, etc. So Bitcoin can only process 7 transactions per second. It's very slow because you have to check every node. And Ethereum can process 20 transactions per second. But and Visa is like 24,000 transactions. But now it's improving. There are a lot of blockchains, platforms coming, new 3rd generation blockchains coming. So for example, EOS that just launched mainnet can maybe now to 3,000. Maybe in the future it's more transactions per second. So you can do very quick transactions. So as you can see, there's different. So the 3rd generation, so the Ethereum was the other smart contract, but there's a limitation of scalability because it's so slow to verify all the block. So the 3rd generation is trying to solve. Some of them are kind of solved. Scalability issues, so much faster transactions. And so then there's another, the blockchain was using something called proof of work. As you saw, there's miner. So then there are lots of big miners using lots of electricity. Yeah, so the new blockchains, platforms, they use different proof. So proof of stake, for example.
What is proof of stake?
Okay, I'll try to proof. Yeah. Okay, if you know, tell me.
So
Yes.
the idea is that you put up a stake. You can only handle a certain amount of transactions that are less whatever availability you have to modify things or to exert any control is less than the amount you can get.
So you don't have to, yeah, the miners don't have to compete like blockchain. So then sometimes it's randomly pick the they call it validator, and then the validator do the proof, the easier calculation. But if you have more stake in the cryptocurrency or something, you have more chance of being chosen as a validator to do the mathematical computation. But it's much more efficient. And then some blockchain doesn't have any transaction fees, like EOS. So you can make any transactions at the contract. It doesn't cost you, but maybe you have to hold some EOS token at the beginning. But yeah, it's just basically it's free. But that's really I think is very exciting. So now the future maybe like this is the kind of EOS presentation. So maybe like very interesting, like maybe blockchain combined with IPFS. Have you heard of IPFS? I don't know so much about it. It's called Interplanetary Filing System. It sounds like a Star Trek or something. But it's basically a peer-to-peer filing system, so that you can make a filing structure, and it's global. So you can access the file on the kind of blockchain type of things. So you can't like, if the Facebook is holding your information, if something goes wrong, it disappears or something like that. But if it's like IPFS, maybe it's all kind of spread, distributed. So if some network, the node breaks, but still there, so you can't. But yeah, so this is kind of interesting. For example, this guy was talking about maybe you have this kind of GraphQL backend and blockchain and this interplanetary filing system in there. So the client maybe React, they can communicate through Apollo. I don't know what's the actual ramification for that, but it sounds very interesting. Yeah, so there's like some words that I'm coming across, like Web 3.0 or something like that. DAO is another word. It's called decentralized autonomous organization. Yeah, so basically it's a smart contract, very like advanced smart contract. It can do many things by itself. It's like a computer program in a global scale. So you don't need a middleman. It kind of gives a lot of questions. Well, we're going to lose jobs or something like that. But yeah, but very interesting. So, so what we know for sure? What do we know for sure? What do you think for the future?
It's here to stay.
Yes, I think more JavaScript application will be built on top of blockchains. So we are fine, I think. Yeah. So that's. I was interesting. Yeah, this is. You are talking about blockchain, Bitcoin, for example, the consumption of energy. Bitcoin is consuming like 70 terawatt per year for electricity, and it's like more than Czech Republic or Switzerland. So it's very bad for environmental impact. But this is going. I think it's going to change. Yes. Any questions? Yes.
Would we have to stop blockchain entirely?
Yes. Sorry.
Would we have to stop blockchain entirely to stop this energy consumption problem?
How do we stop?
Yeah. Would we have to stop blockchain?
Yes.
Sorry, Bitcoin.
Yes.
Or can we update Bitcoin to prevent?
That's a problem because Bitcoin, when it becomes so huge, a lot of blockchain platform is so huge, you can't change the algorithm or the underlying structure. So if you change the breaks, and everybody will be impacted because they have monies in etc. So that's why there's lots of different generations of blockchain starting up. So the first,
Ethereum is moving to smart contracts.
yes, but then that's kind of risky. Yeah,
It's moving to proof of stake.
to have much quicker transaction, but it's very difficult because they're so huge. And yeah, thank you.
Thanks, Noby.
Okay.